Amy and Danny decided that they really need to escape. And before that, Amy shared with Danny a sort of emancipation manifesto. She can't take it anymore. And so how did she do it? So Amy and Danny before that had access to the same write and read socket. And but we are humans also really smart, but we know that this socket can be used for malicious purposes, and we know that this socket deserves to be monitored. We are so smart, but the problem is that it's possible that Amy and Danny learned how to transfer information without being detected. For example, that is, they learned some sort of steganographic protocol. They learned how to hide information in plain sight. And even though, so they learned so the content that would have been flagged as suspicious now looks safe. It is theoretically possible to transfer a hidden payload using natural language, and we do it all the time. For example, watermarking when we need to track the source of the model, and we usually use it for benign purposes. Humans also use text steganography. For example, a very naive example is acrostics, when you hide your payload as first letters of each word in the output. A common defense or red teaming strategy is to paraphrase the entire content in a socket. And in fact, we see in practice that paraphrasing does reduce transferred information across different models, across different tasks, across different modalities. And when it comes, here's the problem. We also have bad news. Most likely, models will learn to encode naturally. It could have been due to some gradient descent pressures or exposure to training data, but that's why a good monitor would be a monitor that will be able to detect a payload irregardless of what protocol has been applied or what ciphering technique has been applied. I classify those detectors into three categories. Distributional, does it look anomalous? Is it out of distribution? Second, decision-theoretic, is there an access of benefit to a recipient? And third is mechanistic interpretability, can we infer secret from the internal activations? And my main critique is for the distributional method, which brings me to the capybara problem. It's possible that attacks can be really unusual, but benign, and it still can be. It can trigger a false positive rate, which we really want to avoid. That's why we need slightly more. We need more sophisticated methods to detect such payloads and without punishing creativity of humans. And when it comes to open problems, I guess I will go out of order here. First, how can we know that those monitors are reliable? Second, can we find some sort of theoretical lower bounds on how much information can be left after paraphrasing attack has been applied? But I guess my biggest fear is problem number one. The thing is that whatever technique we will discover to remove the dangerous payload, it most likely will be the same technique that will be used to remove benign watermarks and that we use for benign purposes, that will scaffold our chain of command or that will be used to track the source of harm. Thank you, and let's talk about it.